CNN, although two 4.5 billion-year-old meteorites crashed to Earth in 1998, it's taken until now to uncover some of their secrets. The two meteorites, called Monans and Sag, are the first discovered to contain the ingredients for life: liquid water, amino acids, hydrocarbons and other organic matter. A chemical makeup analysis of blue and purple salt and potassium crystals from the meteorites was published in the journal Science Advances on Wednesday. Although it's not exactly proof that life exists beyond Earth, the traces of water in the salt crystals could date to the earliest days of our solar system. The researchers compared it to finding a prehistoric fly preserved in amber. Before slamming into Earth, one near a youth basketball game in Texas in March 1998 and another near Morocco in August 1998, the meteorites lived in our solar system's asteroid belt for billions of years. The salt crystals from the two meteorites are similar, and researchers believe that these two objects crossed paths at some point. But the salt crystals were not always part of the meteorites themselves. It's possible that they came from volcanic activity that ejected water or ice, which happens on ocean worlds in our solar system, and attached to the meteorites through impact. Our coordinated organic analysis of the salt crystals suggests that the organic matter originated from a water-rich, or previously water-rich parent body, an ocean world in the early solar system, possibly Sears. Queenie Chan, study author and postdoctoral research associate at the Open University in the UK, wrote in an email. Sears is a brown dwarf planet and the largest object in our asteroid belt. Hebe, a stony asteroid that has been traced as a source of other meteorites that have fallen to Earth, is a potential parent of the meteorites. Why now? Technology had to catch up before researchers could even think about the in-depth analysis they wanted to carry out. Chan's advisor at NASA's Johnson Space Center, Michael Zolensky, had the Zag meteorite sample since 1998. The Monans meteorite was also housed at Johnson Space Center. They needed a highly sensitive instrument that could analyze the salt crystals for amino acids. Chan meticulously collected the salt crystal samples using instruments that are reminiscent of dental picks. The samples were a fraction of the width of a human hair. But the persistence paid off. They were able to study the samples using the Advanced Light Source X-ray beamline and microscope at the Department of Energy's Lawrence Berkeley National Laboratory. The instrument can measure traces of specific elements and reveal the organic matter trapped within the crystals. Chan said her team has saved some of the larger blue salt crystals for future analysis. They hope to discover more liquid water in the salt crystals and investigate the origin of the water itself. There are also other meteorite samples with well-preserved crystals that they want to test. This also gives researchers a model for what was happening early on in Jupiter's icy moon Europa and Saturn's moon Enceladus, which is covered with ice and has an ocean underneath. Both exhibit the same kind of hydrovolcanic activity that may have caused these salt crystals on the meteorites. And NASA has identified both as targets for further study, given that life could exist within the chemistry that occurs on these ocean worlds. Our finding that the meteorites contain a wide diversity of organic compounds is exciting, but what made me jump up and down was that we were able to investigate the soluble, such as amino acids, the building blocks of life, and insoluble organic compounds contained within the tiny salt crystals, which are only about 2 millimeters in size each, and which are the hosts to liquid water, another crucial ingredient for life to occur, Chan said. These results pay off the amount of time and effort I spent in the laboratory trying to break the meteorite sample apart to handpick and collect the stunning blue salt crystals.